Okay, this is the video for dimensional analysis. We'll talk a little bit about metric units, but primarily this will be focused on dimensional analysis. So before we start getting into the dimensional analysis, which is the solving of problems using these units, we have to talk about metric units or SI units. Why do we have them? What is the purpose? Well, here in the US, we don't use them, unfortunately. For all intents and purposes, when we're in chemistry class, we are not considered part of the US measurement system. In chemistry, we will be using metric and SI, which stands for Système International, SI units. We have to have a standard. Way back when we were first starting to do what is now considered science, you had different regions of the world doing their work with their own custom units, and so no one could really compare their results and their findings with each other. If I did an experiment in Germany, you couldn't compare it to anything in France. You couldn't really compare it to an experiment that was done in France. It just wasn't how the world works. So we all got together, scientists around the world got together and came up with essentially a set of units so that regardless of where you do your experiments, you can have a comparison between multiple scientists doing basically the same experiment or a similar experiment. There are 4 base units that you have to memorize. That is the base unit for time, length, mass, and temperature. So for time, it is the second. The symbol, you can either use just a single lowercase s, or you could say SEC, sec. You do know the conversion from seconds to minutes, and to hours, and to days, to weeks, to years, all of that, but the base unit is the second. The unit of length that we'll be using is the meter, with the lowercase m. You've heard of a bunch of different versions of that, the kilometer, the centimeter, the millimeter. We're going to be using all of those, but notice that the base unit is the meter. Mass, the base unit is the kilogram, kg. Notice the gram is in there. It's the only base unit that actually does have a prefix, kilo. We'll talk about prefixes here in just a second. You might already be familiar with those idea of prefixes from previous science classes, though. For the time being, time, length, and mass are going to be the ones that we deal with pretty exclusively until we get to the spring semester. In the spring semester, we'll bring in energy and we'll bring in temperature. The base unit for temperature is considered the Kelvin, with a symbol that is a capital K. Most of you probably have never heard the unit Kelvin. That's okay. You're more used to Fahrenheit or Celsius. We never use Fahrenheit in science class. Please, please, please never expect to do any of your math in the units of Fahrenheit. Basically, as far as we're concerned, it doesn't exist. We're going to be doing a lot of work in degrees Celsius, which can also be considered a base unit for temperature. But we'll get into temperature more in the spring. Don't worry about those last two, amount of substance being the mole with the symbol MOL. We'll talk about that in Unit 9 when we get down to December. Current, we'll never talk about in this class. You will deal with it in physics, but just so you know, the base unit is considered the ampere with the symbol capital A. But really, time, length, and mass, with eventually temperature, those are going to be your big base units. Those are the ones you have to memorize. We will not give you anything that says the base unit of time is seconds. You just have to know it. So other units that we're going to be using a lot in this class are not considered base units, but are considered derived units. Derived units are any unit that you create by multiplying and dividing the base units. So density are grams per milliliter, grams divided by milliliters. Volume can have the units of centimeters cubed, which is centimeters times centimeters times centimeters. So 3 base units multiplied together. Force, we will never talk about force in this class. You'll really talk about it in physics. That's what they use for a lot of the year. The units are considered the Newton, but in science, the Newton is really made up of kilograms times meters per second squared. So kilograms, meters, and seconds are all base units. It's a unit that is created by multiplying and dividing a whole set of base units. just know your definition of derived units being a combination through multiplication division of base units. Okay, now we get to the fun part, dimensional analysis. You might have used dimensional analysis in the past and not called it dimensional analysis. You might have called it dimensional analysis. Other terms that we've heard for it are like the railroad tracks or something like that. But it's a method to convert between units using conversion factors. And you know a lot of conversion factors already coming into this class. You know that for every 1 foot, you have 12 inches. You might know your prefixes, which we're going to talk about in just a second, milli, kilo, centi, all of those fun ones. But for example, if I said, okay, you have 2 minutes, how many seconds of that, or how many seconds is there in 2 minutes, you could probably very quickly tell me that if I have 2 minutes, you have 120 seconds. Because for every 1 minute is 60 seconds, well, 2 minutes is 2 times 60, which is 120 seconds. That's great. But maybe I said, how many millimeters are in a mile? Or if I have 5 millimeters, how many miles is that? Well, I don't think you could do that in your head. I can't do that in my head. I wouldn't even want to try. But I could set up a series of conversions to go all the way from millimeters to miles. If I really wanted to do that problem, I would have to go millimeters to meters, meters to kilometers, and then kilometers to miles. But I'd have to know all of those individual conversions. Millimeters to meters first, then meters to kilometers next, then kilometers to miles. We'll tell you some of those. You have to memorize some of those. But you'd have to have a series of conversions ready to go. So a conversion factor is that relationship between two different units of measurement. So for example, 1 foot is 12 inches. That's a conversion factor. You can write this relationship, 1 foot equaling 12 inches, as two different conversion factors. You could have 1 foot divided by 12 inches, or 12 inches over 1 foot. That's effectively the same thing. Everyone in the universe agrees that for every 12 inches is 1 foot, which means if you think about that in terms of math, that's like writing 2 over 2. It's the same measurement. It's just with two different units, inches over feet. Conversion factors do not change the value of a quantity, only the units. It's effectively the same as multiplying by 1. Any conversion factor that we're going to be using in this class can be considered an exact number. What is an exact number? It's basically exactly what it sounds like. It is a number that either is very clearly defined and accepted, or it results from a count, and you have a very exact count. So, for example, if there were 30 students sitting in my room, and I said, okay, I'm going to count all of you, there's 30 students, that's an exact number. There's not 30.2 students, there's exactly 30. If I had a stack of 5 pieces of paper and I sat there and counted 1, 2, 3, 4, 5, there's no pieces of like small torn pieces of paper. There's exactly 5 pieces of paper on my desk. It is an exact number, therefore it has an infinite number of sig figs. I am confident that there are 30.000000 ad infinity students in my classroom. Going to more useful pieces of information, for every 1 foot is exactly 12 inches. That is the universally accepted conversion between feet and inches. If I have 1 liter, that is exactly 1,000 milliliters. 1,000.00000000 infinity milliliters is 1.000000 infinity liters. So whenever we talk about exact numbers or conversion factors, you basically don't have to bring those in when we're thinking about, okay, well, what about my multiplying, dividing, sig fig rules? You just assume it's infinite, so it's never going to be the least number. Okay, and you'll see what I'm kind of talking about when we do some of these problems. Okay, so let's talk about those conversion factors. Which ones do we need to know? Which ones do we not? Any conversion between the English system, which is units that you know, and metric, we will give you. Do not memorize any of these. Now, you might already know some of these. So, for example, you know that 1 year is more or less 365 days. Yes, I know it's 365.25. We're not going to go down that road right now. We're just going to assume that every year, if we make you convert it, is 365 days. Or every 1 year is 12 months. Some of those you might not know. 1 pound is 454 grams. That's the conversion. You probably don't know that. You probably haven't ever had to use that. You don't have to memorize that one. 1 kilogram is 0.621 miles. 1 gallon is 3.7854 liters. Don't memorize those. We will give them to you. Now, you might remember them because you're going to be using them a bunch, but don't waste memory trying to memorize those English to metric. Other conversion factors that we could give you is maybe we give it to you in a problem. So let's say we have the density of mineral oil is 0.85 grams per milliliter. What is the volume of 66.0 grams of oil? You're going to have to convert from grams, the unit that I start with, into milliliters, the unit of volume, and you're going to have to use that guy right there. You can identify it pretty early on as a conversion factor because it has two separate units, grams and milliliters. That's your clue that that number there is just a conversion factor. So we'll give those to you in problems as you need them. Last but not least, the three that you are going to have to memorize are the three essentially within the metric system: milli, centi, and kilo. Yes, we know that there's a lot of other prefixes, deci, deca, etc., micro, nano, mega, giga. You don't have to know all of those. The three that you have to memorize are milli, centi, and kilo. Okay? Those three conversions. 1 kilo, okay, 1 kilo of anything is 1,000 of that thing. So 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. We're essentially just adding kilo to those base units: meter, liter, and gram. Centi is one of the two smaller ones. So your base unit to a smaller unit. 1 gram is 1,000 centigrams. In 1 meter, your base, there's 100 centimeters. In 1 liter, there's 100 centiliters. So it's 1 base to 100 centi base. So let's just make up a unit, wazoos. 1 wazoo would be 100 centi wazoos. Really doesn't matter what your base unit is. Centi just means you have 100 smaller versions of that base unit. Last but not least is milli. It's the other smaller prefix. 1 gram is 1,000 milligrams. 1 meter is 1,000 millimeters. 1 liter is 1,000 milliliters. Using that made-up unit we just used, 1 wazoo would be 1,000 milliwazoos. Milli is just a prefix that says you have 1,000 smaller versions of that base unit. So you do have to memorize kilo, you have to memorize centi, you have to memorize milli. The other one that you have to memorize is not a crazy complicated one, but it's one you might need every once in a while. And it's a pretty simple one, that 1 milliliter of anything is 1 centimeters cubed of that thing. Also 1 cc. Cc just means centimeter cubed. CC. Just know that's 1 milliliter to 1 centimeter cubed. It's a volume conversion. You'll use it every once in a while, but it's not a crazy big one, but it is nice to just have in your back pocket for when you do need it. So we've talked conversion factors to death. Let's actually talk about how we're going to use these conversion factors, how we're going to do some dimensional analysis problems. Well, it follows a series of steps that I'm going to talk through, but may not make a whole bunch of sense until we actually start using it in some example problems. So let's read through this pretty quickly. First, you're going to start with a given, which means in the problem, we will give you a number with a particular unit. That's your given. That's the number that you're going to start with when you start your dimensional analysis. Before you do any math, before you do any calculating, before you do any typing, anything, you need to figure out step 2. Where are you trying to go? Do you want to end in milli or killi, or do you want to end in a completely different unit? You got to figure out where you're going to end so that you can get there from where you're starting. So you got to know your start point, got to know your end point. Then you're going to make a pathway. And so essentially you're going, if you know A to B, you're going to figure out what roads you need to drive to get from A to B, what conversion factors, what steps do I need to get from where I'm starting to where I'm ending. Step 4 says make sure all undesired units cancel. In other words, if I start in millimeters and I want to end in miles, I want to get rid of millimeters. I don't want to have it in my end problem. I want to end with only miles in my units. So I'm going to have to get rid of millimeters. I'm probably going to have to get rid of meters along the way, kilometers along the way, and you'll see what I'm kind of talking about with undesired units as we do an example problem or two. Step 5 is real simple. Once you've set up this system, once you've set up all of this pathway, then you can get your calculator out. Then you can actually do your math. Type, 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 type. You're going to multiply everything on the top together. You're going to multiply everything on the bottom together. Then you're going to be able to get your final answer. Again, I know it's hard to see this without actually having the work in front of you. We'll do an example problem here in just a second. Last but not least, you got to make sure your number of sig figs are right. You're doing multiplication division, so you're going to have to essentially be whatever number of sig figs you start with is probably going to be the number of sig figs that you need to end with. Okay, so we ran through all of those steps. Let's actually do an example problem so that we can kind of see how these steps work. So example 1, 57.98 milliliters. My starting unit is milliliters. That's my given right there. Step 1, find your given, milliliters. Step 2 says figure out where I'm trying to go. Well, I have milliliters. I want to end with just liters. So I want to go from milliliters straight to liters. There is a conversion that goes from milliliters to liters. In fact, it's one of the 3 metric ones that you're going to have to memorize. So we've kind of started to identify the conversion factors we're going to need, milliliters to liters. And we're going to set up this little diagram that looks a little something like that guy right there. And the first thing that we're going to write is our given, 57.98 milliliters. That's our starting value. We don't have to put anything on the bottom because there's nothing that needs to sit on the bottom. There's no units on the bottom. There's no numbers underneath. It's just 57.98 milliliters. If it bothers you that there's a blank space underneath that number, that's fine. You can put a 1 there. If you don't have to put the 1 there, if you're okay with it just saying 57.98 milliliters, you're good to go. So we have our given. We know where we want to end, liters. We know that there's a conversion between milliliters and liters. There's a conversion factor, and I could either write it 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter. That's the same conversion factor. It's the same. It's written in the same way, effectively. It's just what am I going from or to. Your job is to pick the right way to write it in our work. Well, if I have milliliters on top, and I want to get rid of milliliters, I don't want to have milliliters in my final answer, I just want liters, I have to figure out how I can make milliliters cancel out. Well, in math, you know, if I have a 2 on top and a 2 on bottom, I can cancel those things out. They eliminate each other. Well, units in chemistry, when we're doing dimensional analysis, work the exact same way. If I have milliliters on top, in order to get rid of milliliters, in order to cancel them out, I need to have milliliters somewhere on the bottom. Well, if I choose to write that conversion factor, there's my milliliters right there on the bottom. So I'm going to write it like that, 1 liter over 1,000 milliliters. Now when I look at my units, my milliliters cancel each other out, and I'm left with liters. Because that's the unit that I want at the end of the day, I only have 1 step to go on this problem. I can stop at that point, I can get my calculator out, and I can type. 57.98 times 1 is 57.98. Divided by 1,000 is going to be 0.05798 liters. I start with 4 sig figs, so I should end with 4 sig figs. It's that simple. Okay. Let's do another one, just a little bit slower. Example 2, 5,005 milliliters, and I want to take my millimeters all the way to miles. Okay? Well, I don't know a conversion directly between millimeters and miles, but one of the three that I had to memorize, or that you have to memorize, is millimeters into regular meters. So let's start with my given, 5,005 millimeters. And I can go 1,000 millimeters into 1 meter. I'm going to choose to write it this way so that I have millimeters on top and millimeters on bottom. See how that? Hopefully you can see how that kind of cancels out. I could flip that, so I have meters on bottom and millimeters on top, but then my millimeters don't cancel out. So I don't want to write it that way. It doesn't. The math won't work. So now I'm in meters, but I want to end in miles, so I'm not done. I still don't know a conversion directly from meters to miles, but I do know a conversion between meters and kilometers. Whoops. That's another one that you're going to have to memorize. Meters to kilometers, meters to millimeters, milli to base, kilo to base. Just one of the three that you have to memorize. Well, my meters cancel each other out, one on top, one on bottom, and now I'm left in kilometers. Well, I don't know a conversion between kilometers and miles off the top of my head, but if I look up here, I'm given a conversion between kilometers and miles. It's between metric and English, so I'm not going to make you memorize that one. I'll give you that one, okay? But you do have to know how to use it correctly. Since I have kilometers on the top part of my dimensional analysis, I'm going to have to put kilometers on the bottom in the next step. That way my kilometers are going to cancel out with my kilometers. Well, since kilometers are on bottom, I'm going to put miles on top. And according to that conversion right there, every 1 kilometer is 0.621 miles. And I can sit back and I can make sure that all of my units cancel out appropriately. Meters, meters, miles, miles, kilometers, kilometers. So the only thing I'm left with is my miles. At this point, I'd pull out my calculator. 5,005 times 1 times 1 times 0.621. Everything on top multiplied together. Divided by 1,000. Enter. Divided by 1,000. Enter. Divided by 1. Enter. And that gives me 0.031081105 miles. Now the last step in all of these problems is always significant figures. I start with 4. All of these conversion factors are allowed to be assumed to be exact numbers. In other words, you know that there is exactly 1,000 millimeters in 1 meter. You know for a fact there is 1,000 meters in 1 kilometer. You know for a fact there is exactly 1 kilometer to be 0.621 miles. Those are exact numbers, which means for our intents and purposes, those are infinite in Sig Figs. Well, I started with 4. This step has an infinite number of Sig Figs. That step has an infinite number of Sig Figs. This step has an infinite number of Sig Figs. So the least number of Sig Figs there is 4. So we're going to take our final answer that we got way over here, and we're going to round this guy 0.031081105 to 4 significant figures, which means our final answer will be 0.03108 miles. 4 Sig Figs, 4 Sig Figs. Those first 2 zeros don't count because they're leading zeros. That middle 0 counts because it's a sandwich 0. Hopefully you've kind of started to get at least a little bit of grasp. You're starting to see kind of how this works. So let's take a little step up. Example 3 says that I have 55 miles per hour, miles over hours, and I want to convert that into kilograms per minute. So in example 1 and example 2, I was changing a single unit, milliliters to liters, or millimeters to miles. This time, I have a couple of things that I have to worry about. I have to get my miles into kilometers, because those are both distances, and I have to convert my hours into minutes. Both of those are my time. So I'm going to have to convert 2 units this time. Here's the nice thing. The general rules, the general steps are all exactly the same. It just adds 1 or 2 extra little conversions that you have to deal with. But if you're letting the track set up your conversions for you, if you're letting the units tell you, okay, what does my next step need to be, you'll be able to handle this no problem. Okay, so let's set it up. 55 miles over hours. Now notice it's a little different than how we set it up in example 1 and example 2. Those just had a single unit that stayed on top, and I had nothing underneath. Here, because I have that dash right there, that tells me that it's 1 unit, miles, over another unit, hours. You don't have to put a number with those hours on the bottom, but if it bugs you, you can put a 1 there, and it's okay. It's the same number. Try to get used to not having that number there, but if you need it, you can put it in there. Your math's not going to change. So I have miles and hours, and you're allowed to convert in whatever you want, in whatever order you want, as long as your conversion factors all work out. You can convert miles into kilometers first. You can convert hours into minutes first. It literally doesn't matter. Your math will still be the same. So let's just say that we're going to convert hours into minutes first. You can do miles and kilometers first if you want to, but let's convert hours into minutes first instead. So hopefully you know or have remembered that for every 1 hour, there is 60 minutes. Well, since my hour is on the bottom, I want to ensure, to cancel it out, that I have hours on the top. That way my hours cancel out my hours. And I want minutes to be on the bottom. That way it matches the minutes that I want my problem to end with. And I know my conversion for every 1 hour is 60 minutes. Hours cancel out hours. I'm in minutes. I want to end in minutes, so I know I'm done with that portion of my conversion. But I'm not done with the problem yet, because the problem wants me to end in kilometers per minute, and right now I have miles over minutes. So I have to do another conversion in order to get my miles into kilometers. Luckily, again, we're still going to use that same one that we used earlier. And since I have miles on top, I'm going to ensure that I put miles on the bottom in my later step so that my miles on top cancel out my miles on the bottom. And I want to go from miles into kilometers because that's what my conversion says I have, miles to kilometers. And it tells me that for every 1 kilometer is 0.621 miles. My miles cancel out my miles, and I can look at my units before I do any math to make sure that I've set this up correctly. I want to end with kilometers over minutes, and if I look at my units, I have kilometers on the top and minutes on the bottom, kilometers over minutes. So that lets me check my work before I do any typing. 55 times 1 times 1 is 55, divided by 60, divided by 0.621, and that gives me 1.476 kilometers per minute. Last step, significant figures. If I start with 2, I need to end with 2, because that's how we set up all our problems, which means I need to round my 1.476 to 1.5 kilometers per minute. This is the work that we're going to be looking for. We're going to be looking for these conversion factors. You might be able to set it up a little bit differently, and that's okay. As long as we're able to follow your work, we're able to see all of these individual conversions, you'll be okay. But you have to show us the work. It doesn't matter how simple. We don't care if you can do the conversion in your head. You need to be able to show us some work, because when you turn in your problems, we need to be able to follow your thinking on paper. Okay? You can't be there standing over our shoulder when we're grading your work. So please make sure you're showing us the work in some way where we can really clearly follow your thought process. Here's the last example problem that we're going to do in this video. So example 4, an electric car gets 2.5 miles per watt of charge. The average cost to charge the electric car is 11 cents per kilowatt. How much does it cost the driver to travel 18.5 miles to work? I'm going to move it over a little bit so I can get a little bit more room. So we talked earlier about how can we identify conversion factors in story problems and word problems. Well, what you're really going to look for, again, are any of these units where you have something per something or something over something. So we have 2.5 miles per watt. That's going to be a conversion factor. Oops, oh, that didn't work quite the way I wanted. That's going to be a conversion factor between miles and watts. It's going to give me a way to convert between these two things that I wouldn't normally be able to convert to. Down here, 11 cents per kilowatt. 2 units means that's a conversion factor. I'm going to be able to use that to convert between cents and kilowatts. Lastly, as I go, how much does it cost a driver to travel 18.5 miles to work? That is a single unit, a single number. That's my clue. That's probably going to be my given. You always want to start with the simplest thing possible. Okay, it's just an easy way to keep track of everything. The less stuff you have to keep track of, the more likely you are to be able to keep your work straight. You know, it's going to be easier to juggle one single ball up in the air versus 5 or 6 things at one time. So always start with the single unit. So miles is the only single unit I have there. So 18.5 miles. Whoops, miles is going to be my starting point. I'm going to erase that and switch it over to the abbreviation, MI for miles. Well, I have 2 conversion factors, 2.5 miles per watt and 11 cents per kilowatt. I can't use the 11 cents per kilowatt yet because I don't have cents or kilowatts. So I can't use that conversion factor. But I do have this number right on top, 2.5 miles per watt. Right now, I'm already in miles. So I can use the conversion factor that helps me get out of miles, 2.5 miles per watt. It's going to let me go 2.5 miles. Notice how I put miles on the bottom, so it's going to be able to cancel out, because I don't want miles at the end of my problem. I want cost. I want money. I don't want miles. So I have 2.5 miles per 1 watt. This number always is attached to the first unit you see. The other unit just has an assumed 1. Okay? So I have 18.5 miles, and I know that I can go 2.5 miles per watt. So I've used this conversion factor already. Don't want to use it again. The other conversion factor I have is 11 cents. Oh, hey, cents is money. That's where I want to end, per kilowatt. Well, I don't have kilowatts yet, but I do conveniently have watts. And since I memorized 3 of my metric conversions, I know, using that guy, that for every 1,000 watts that I have a single kilowatt. Remember, kilo just means 1 kilo of that thing is 1,000 of that thing. So 1 kilowatt is 1,000 watts. Now that I'm in kilowatts, now I can use this other conversion factor. Since I have kilowatts on top, I want to put kilowatts on bottom. And I can put cents on top. I'm matching my units. Miles are going to cancel out miles, watts are going to cancel out watts, kilowatts will cancel out kilowatts, and I'll end because every 11 cents, again, is 1 kilowatt. This first number always attaches wherever that first unit goes. That's why 2.5 was with miles on the first step. That's why 11 is next to the cents in the third step. Well, I wanted to end in cost. I'm ending in money. Therefore, I've done all the conversions that I need to do. I've taken this thing from miles into cents. The last thing I got to do is get my calculator out and start typing. 18.5 times 1 times 1 times 11 divided by 2.5 divided by 1,000 divided by 1. And it tells me that if I have an electric car, which gets that miles per watt, and cost is 11 cents per kilowatt, it tells me that it's going to cost 0.0814 cents every time I travel to work using that particular car. Last thing to check is Sig Figs. Well, if I have 3 Sig Figs there, I should have 3 Sig Figs down at the bottom. I'll rewrite that so it's a little clearer. And sure enough, leading zeros don't count. 8, 1, 4 gives me my 3 Sig Figs. Dimensional analysis is going to be a very important skill. We're going to be using it all year long. So please, 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 practice this dimensional analysis. See this pathway, see step by step. Come see us so that we can write some problems for you and help give you some guidance. Every one of you is capable of learning dimensional analysis. We promise, but it's going to take some practice. It's going to take doing the same procedure over and over and over and over again until you basically are able to sit there and just pound out these problems over and over and over again. So if you're struggling or you don't know why did you do this, why did you do that, please come see us and we'll be happy to explain it to you.